Hello everyone, and today we'll be seeing one of the problem from Geeks for Geeks. It says subarray with at most k distinct integers. The problem goes like you are given an array ARR of positive integers and an integer k. Find the number of subarrays in ARR where the count of a distinct integer is at most k. And there is a note saying that a subarray is a continuous part of an array. Going to an example, we have such kind of an array. We have k is equal to 2 and we get an output as 9. How do we get an output like that? So you see, this can be a subarray of having one distinct element which is lesser than k, which is 2, so it's a valid. So I'll take 1, I'll take 2 as well, 2 or this 2 as well, and 3 as well. So these all are valid. Now can I take 1 2? Yes, obviously. Can I take 1 2 2? Yes, because the distinct elements are still 2. Can I take 1 2 2 3? No, because here the distinct elements are 3, which is 1 2 and 3, which we cannot take forward, and hence we wanted to remove, do not consider this, and we wanted to consider 2 to 3 instead. Nice. So still the question remains, how are we going to calculate this? So one thing is, you can go ahead and you can compute each and every combination, and that would be your brute force approach. Are we going to apply brute force approach? No, not yet. No, we are going to do an optimal approach. So the optimal solution goes like, we have an array like this with provided k is equal to 2 for index 0, for 1, 2 and 3. So for such kind of array which we have, we can go ahead and say that, hey, this is valid. All individual elements are valid, first of all, because all individual elements would give at max 2. So how can I say that, hey, this element is till 0 to 2, how many numbers are valid? I know if it is 1, then one element is valid. If it is 2, then 2 elements individually plus 1 comma 2, this is valid. So now I'm running for count. Like, how can I get the count? You see, 1 is valid, 2 is valid, 1 2 is valid. So here we have count as 3. Cool. Count is equal to 3. Now for 1 2 and 2, how can you compute this? This was for 1 and 2. Right now I'm not worrying anything about how I can get the distinct count. I'm just worrying, or I'm just focusing on concentrating about one thing, that how can I get a count. So this would again give me 1, this would give me 2, and this would give me again the next one 2, and again we also have 2 2's, individual 2's within our array, within our consideration of count. We again have 1 2, we again have 2 2, we again have 1 2 2, and for this you have the count as 1 2 3 4 5 6. You have 6. Interesting, pretty much interesting, that from initially 3 I just added 1 2 within this, right? Like, then this last 2 I have added, and the count became to 6. This is required. This is one thing you need to know. How are we going to compute the count? That means on addition of any element which is valid. Here 2 was valid. Hey, instead of 2, if I get ahead and enter 3, that was valid? No, that is not valid, because addition of 3 would give you a distinct count of 3, so that was not valid. So 2 is valid, and my intuition comes over here and says that, hey, from 3 to 6, on addition of any element which is valid, you consider the entire array and sum it up. What do I mean with it? What do I mean with that? So you had an index from here 0, as 1, as 2. Now you went ahead, you said that hey, from 2 to index 0 I want the elements. How many elements are there? 3. So I'll go ahead and I'll add 3 to our list, and that's how I'm going to proceed with that. Cool. This might not look very good to you, but this is how we incrementally go ahead and approach this problem. Now, how do I compute duplicates? How do I compute with duplicates, I would say? Now, at most k, yeah. So duplicates, how do I understand duplicates is there. So a very good data structure to understand duplicates is hash map. Why not hash set? Because hash map not only gives you integer mapping from any integer value, but it also lets you maintain the frequency of how many times it occurs. So here 2 is occurring 2 times, so I can map 2 to 2. Nice. With that approach, let's get started. How are we going to do this? Same. We are going to implement a sliding window protocol. Not protocol, but sliding window pattern. In this pattern, we will have a start pointer and an end pointer. And a start pointer and end pointer would be defining a valid window or valid subarray, which satisfies the condition. And now within that subarray, I want a count of how many can happen. And you know how many can happen. What is the formula for this? It says this one. From 0 to 2 or 2 to 0, how many can happen? There is 3. So yeah, from 3 to 6 we got this number, right? 6 minus 3. Anyways, if it's not clear to you, we'll be understanding more upon this while we implement. So we have an hash map over here, which would map from integer to integer. I'll name it as map, which would be a hash map. Okay, we'll have a count, which initially is 0, and this we would be returning as our answer. As I mentioned, we would have 2 pointers, which is start and end. I would denote int start as 0 and end, and I will have a for loop for int end is equal to 0, end is less than a dot length, end plus plus. So end pointer is the one which would be continuously running, and we need to adjust our start pointer in such a way that hey, the array is valid. I'll have a map. I'll put the upcoming element. What is upcoming element? Upcoming element is denoted by end, which would be a of end map dot get or default if I have that. So I'll get it. If I don't have that, I'll consider 0, and ultimately I'll add plus 1 because I'm seeing that, so I'm adding updating the frequency. Now here comes the part that if my map dot size is greater than k, that means I have more distinct elements. I wanted to remove some, and from what point I would be removing. It's obvious that I would be removing it from the start itself. So I'll have an x, I'll have updated count, which would give me map dot get a of start, and I'll get the number. Update account means I'm removing that. I'll say trying to remove element. Hence, the count is decremented. So once you remove an element, you decrement the count. That is pretty much obvious. And there can be two things that hey, updated count can become 0. That means element no longer exist, or it would just go ahead and update the count. That means like from 2 elements I'm now seeing only 1 element. In that case I will just map.put a of I with update count. But if element no longer exists, I don't want that element in a map, so remove that element. Which element? A of end. It's not I, it's end. Yeah. And how many times I'm going to do this operation? I'm going to do this operation until and unless this condition fails. So sorry, this condition is passed. That means I wanted map size to be lesser than or equal to. So it would not be if, it would be while. Interesting. Now once we are out of this, I wanted to update the count. Why am I updating the count? Because when the control is coming over here, I am sure that array or subarray, I would say subarray, is valid. If it wasn't valid, the loop would never end for this. Again, if I'm valid, I'll have to count. What is the formula of count? 2 to 0 count is 3. That means I have end minus start plus 1. This is what it will give the count of numbers within the subarray. So end minus start plus 1. And we have a count. This loop, outer loop, for loop, would run till the end of array, and once it is completed, we have our count, we are returning the count. Makes sense. Let's compile this code. Okay, updated count. It is updated count. It should be update count. Update count is not very suitable name, but anyways, it says okay, we have a logical error here. What is it? Map dot size is greater than this. Okay, once we are considering this start element, we need to update the start element. So my bad, start plus plus, because now once we have removed the start, we are no longer considering the starting point to be that. We are updating the starting point, right? So let's compile this one. It works well. The sample test case is passed. Let's check for rest all the test cases. Okay, it is failing. Why it is failing? It gives a null pointer exception. Interesting. And why and where? And number 42. This is new, what I'm seeing. That means you haven't seen start. This is weird. Why haven't you seen start? Oh, okay, because you haven't seen the start, because start is moving forward. We don't want start to move forward. It should be less than or equal to end. Cool. Let's check with that particular case which was failing. Yeah, it is failing again. Nice. Very good. Let us dissect this one. I'm not sure about you, but whenever few test cases fail, I see it as an opportunity where I can fix it. So 3 I'm taking, 10 I'm taking, 3 to 10. It's failing over there, so 3 to 10 I'm just taking 10. Nice, good. you get null here. That is the problem. Why do you get null here? If start is already visited, because start was already entered here. Okay, I see now. Updated count, we don't wanted to remove the end element, we wanted to remove the start element. It was a very silly mistake and I was looking at the wrong place. So let me check this one now, and it should. Why it is failing again? Because I'm updating start here. I should not do that. Makes sense. Start and update count should be here. Cool. Silly mistakes here and there again. Once we update it, then we wanted to update the start. Once we remove that element, then update the pointers. Thumb rule. Very uncommon to forget this, but yeah, you don't want it to do these things. So yeah, this was a problem and we had few hiccups, but ultimately we solved this one. The expected time complexity and space complexity, we adhered that. And how can we make sure that space complexity is O of k and not O of n? Because of this condition. If the map size is beyond k, we don't allow it. So this condition forces the map size to become not more than k. That is the reason space complexity is O of k. Tags, obviously it's a sliding window, arrays, and data structure algorithm. For more such kind of content, click the video on your right and I'm sure you'll not see hiccups over there. Until next time.